Let's practice solving systems of linear equations by elimination. So when we're given a system and we're trying to find the solution and it has this setup, that means we're going to look for additive inverses, because if we have additive inverses, we can go ahead and begin the method of elimination. So additive inverses are those same terms, different signs. So we have a positive 4y and a negative 4y, right? So that means when we add those together, they sum to 0. So let's go ahead and do that. We add our equations. So negative 3x plus 2x gives us negative x. 4y plus negative 4y gives us a 0. And then 13 plus negative 11 gives us a positive 2. So then we're left with negative x equals 2. However, we're trying to get a positive 1x. So we need to divide both sides by negative 1 to get x equals negative 2. Now that's only half of our solution, right? So we are going to take that negative 2 and substitute it back into either the first equation for x or the second equation for x. It doesn't matter which one. We just need to make sure that we're replacing x with negative 2. So I'm just going to pick that second one, 2 open parentheses, and we substitute a negative 2 for x, minus 4y equals negative 11. Notice how everything else stays the same. All right. So we have 2 times negative 2 to give us negative 4. Now we're solving for y, so we're going to add 4 to both sides. So we have negative 4y equals negative 7. And then we divide both sides by negative 4 to give us a positive 7/4. So our y coordinate is 7/4. All right, let's look at our next one. What is the solution to this system? So we're looking for additive inverses, but we don't see any. So that means we need to pick an equation and multiply it by some number to create additive inverses. So take a second to figure that out. Okay, so if we multiply the second equation by 5, we could eliminate the x terms. If we multiply the second equation by 2, we could eliminate the y terms. So it doesn't matter which one you choose. Either way, we'll be able to begin our elimination process. So I'm just going to multiply the whole equation by 2. So that's 2 times x to give us 2x, 2 times negative 3y to give us negative 6y, and then 2 times 3 to give us 6. So I'm going to bring down that first equation as is. And now I can begin the elimination process. So we start by adding the equations. 2x plus negative 5x gives us negative 3x. Negative 6y plus 6y gives us 0. 6 plus 12 gives us 18. And then our last step, divide by x's coefficient to give us x equals negative 6. And then we take that negative 6 and substitute it back in to either the first equation for x or the second equation. I'm going to pick that second equation, so that's going to be negative 6 minus 3y equals 3. We add 6 to both sides. And then one more step, divide by y's coefficient to get y by itself. So our solution is negative 6, negative 3. Now I want you to try this next one on your own. Okay, so we look at our system and we don't see additive inverses, right? But we could either multiply the first equation by negative 3 or multiply the second equation by a positive 5. It doesn't matter which one. If we multiply that second equation by 5, that allows us to eliminate the y terms. And then multiplying the first equation by -3 allows us to eliminate the x terms. So let's practice that. We distribute that -3 to every term in the equation. So x times -3 gives us -3x. -5y times -3 gives us a positive 15y. And then -6 times -3 gives us a positive 18. Now that we have additive inverses with our x terms, see that? 3x and -3x, we can begin our solving process. So we add our equations. Our x terms are eliminated. Y plus 15y gives us 16y. -2 plus 18 gives us 16. And then our last step to solve for y is to divide by y's coefficient. So we get y equals 1. All right, now we're going to take that 1 and substitute it either into the first equation for y or the second equation. I'm going to pick that second one. So we'll have 3x plus 1 equals -2. Subtract 1 from both sides. Divide every term by 3. So we get our solution, -1, 1. All right, one more problem. I want you to try this one by yourself. If you need a push, think about what you can multiply that first equation by to either eliminate the x terms or the y terms. Okay, so hopefully you realize you need to multiply the first equation by a -2. That allows us to eliminate some terms. And it happens to be that here, when we add our equations, our x terms eliminate, our y terms eliminate, and we're left with 0 equals 2. So what does that mean? All right, remember when we're solving a system algebraically and we get to a statement like this where it's false, right? 0 does not equal 2. That means we do not have an intersection point. We have no solution. Now, if you had gotten to a point where it was 2 equals 2 or something, then you know that that means infinitely many solutions. Or if you gotten 0 equals 0, that would also be infinitely many solutions. So again, when you're solving algebraically and you get to a point where the variables are eliminated and you're left with a value on each side, they're the same number, infinitely many solutions, different numbers, no solution.